Hi, everybody. My name is Natale Ruello. I'm the Senior Director of Product and UX at Forward. In this POC presentation at ONUG, you will learn how Forward is helping its users with verification of security in hybrid multi-cloud environments. Before we get into the demo, allow me to recap what Forward does. In a nutshell, Forward Network provides network intelligence that enables true reliability, agility, and security for the IT organization. And we achieve that by collecting, organizing, and making network data useful and actionable. In essence, we create a digital twin of the network infrastructure. To build this digital twin, as you can see on the left, we collect and parse data from all types of network devices in cloud environments: routers, switches, firewalls, load balancers. When it comes to cloud, we support AWS, GCP, and Azure, but we also ingest data from additional external sources like GitHub repository and CMDBs, for example. And those are needed to create even richer assurance and verification security checks. It's not just the network operator, as you can see on the right, that want the insights and the data from the network. It's the executives, it's the security operators, it's the tool teams, and of course, it's the team that are responsible for network security in the cloud. When you deploy Forward, many teams end up gaining insights and extracting value. For example, you can go on our website and you're going to see all different use cases for which our customers have bought Forward. We usually get purchased, they get deployed for a specific use case. Within a few months, the reach of the platform extends multiple teams and covers multiple use cases. I invite you to stop by and check our website for that. When it comes to cloud, as we said, we support the three main cloud providers: AWS, GCP, and Azure. What kind of value do we provide in these environments? First of all, an unmatched visibility. End-to-end visibility is key for security reasons, right? Visibility in hybrid multi-cloud environments, the environments that span from your on-premise infrastructure to your cloud. Once you have visibility, only at that point you can have verification of security policies across cloud vendors, verification of security posture, extension to the cloud virtualized firewalls, and then path networking optimization, for example. At the end of the day, we are the single source of truth across on-premises, private cloud, and public cloud. And this is what we're going to see in the demo. When you log into Forward, what you see is the topology of the network infrastructure laid out on a geographical map. In this demo, we are using a network that mimics what you can expect to see in a large multinational corporation, with on-prem data centers in Atlanta and San Jose, as you can see here in the map, as well as cloud presence in all three major cloud vendors with Azure, GCP, and AWS. If I click on Atlanta, I see a classic on-premise topology with aggregation layer, access layer, some firewall and load balancers. And I will show you also what we see when I click on the AWS, for example, environment. It's important to underscore the diversity of this environment. On-prems, for example, we have multiple vendors, we have multiple operating systems and multiple device types. And in this small network, you see that there are 34,000 lines of configuration, which gives you an idea how challenging it is for a network operator to keep network running. We have a cloud session. You can see some of the statistics when it comes to the cloud that has been modeled for this environment. And just for your reference, we support 26 vendors, 35 different operating systems, and all three major clouds. When I go back to let's go back to the topology area, as I was saying before. Let's click on the AWS US West. Here you can see I have 10 VPCs. These are all VPCs. In this specific location, the communication between VPCs takes place with the transit gateway, but has to go all through the firewall to get cleaned out before it reaches the destination VPC or it gets out to a different location. As you can see, I have different locations here that I can enable and disable, right? I have GCP and AWS. If I click on the prod VPC, for example, I have a connectivity area that describes visually how the traffic comes in and goes out from this VPC. You have web accelerators, the internet gateway, route tables. Then you have a resources area where you have the availability zones, right? And within each availability zone, you have different subnets. Within subnets, you see which subnets is connected to the transit gateway, and then what you have within the subnet. You have, for example, in this backend subnet, several backend EC2 instances that you can click and see details of, right? So very flexible. The idea is that every user can modify this view, extracting the information that they need. And whenever they come back to the platform, the system is going to remember what to display. If we go back here and we click on the GCP icon, we jump into the GCP location. As you can see, we normalize the view, even though we make sure that to keep highlighting the differences between the different cloud vendors. But if I click within a VPC, you're going to see the same representation of connectivity and resource area. And also in this GCP environment, you see different subnets and compute instances. So it kind of a normalized view. So if I go back now to the topology, this is just a topology. It's a map. It's extremely important. We built it to work at scale. We have customers with hundreds of VPCs, for example, which we automatically discover. And it's the bedrock of everything else we do. But in itself, it's not enough for efficient, reliable, and secure operations of the network. So let me now show the deepest and most detailed network connectivity analysis solutions that is available on the market. So in network operations, usually when responding to an incident or reported issue, you need to debug a specific flow. And that's very easy with forward. So you can create your query, to say from this NSX host to an SSH in availability zone 1. As you can see, I'm building the query. As I build the query, I get the results, right? I can add the destination port. So you can see very quickly how the specific flow goes through different locations, from Atlanta to San Jose, back to Atlanta, and then into the AWS first east and then west. So if I click into a specific location, I see what happens there. In this case, I have a VXLAN. So we have a virtualized environment, I have a VXLAN link. The great thing that you can do with forward is the correlation between the overlay, right, which is this one. So you can see it's a VXLAN link with the underlay that supports it. So I click, I see that, where there was a link, a virtual link, and now there is actually the underlay here. So you can debug those kind of problems. So going back here, so the traffic goes to San Jose. If I click on San Jose, I see within San Jose what happens. It comes to Atlanta on the VXLAN link and goes within the infrastructure. It reaches, for example, a firewall, which I again recognize from the icon. And we highlight the most important things for this firewall. We highlighted, the ingress zone with the ingress port, the egress zone with the egress port, and we give a representation that is vendor agnostic when it comes to the forwarding function within the device. I can click see device state. I see the configuration that is responsible for this specific flow. So I have all the information on my fingertip. But the most interesting thing for this presentation is trying to understand what happens when I go to the cloud environment, right? So let's look what happens here. As I was describing initially, the traffic has to go to the transit gateway before it reaches any VPC, has to go to the firewall, getting cleaned up, and reach the VPC, our destination. And you can see these very clearly here. So transit gateway first, we have network functions that explain what is happening here. You have the ingress attachment, the egress attachment. Then you end up within the firewall VPC here, which is represented here, right? You can expand this and understand exactly what's happening. So you land on the subnet, you get on the route table, and if you want to see the configuration similar to what you will see on the AWS console, you can do that, right? You get on the service endpoint, right? You have the service endpoint requester, right, which is the firewall. And then you have the provider, which is going to be a gateway load balancer, which we support. The gateway load balancer does load balancing between two active Palo Alto virtualized firewall that we are able to collect, parse, and model within the network, a cloud network infrastructure. So we can tell you what's happening within a Palo Alto instance where you extended the security posture you had in your on-premise infrastructure. Then the traffic goes back to the gateway, right, to the service endpoint, where now we switch the provider and the requester, and then goes out to the transit gateway and reaches the final VPC where it's delivered. Now think about how difficult it would be to, and first of all, understand how this traffic goes through an hybrid multi-cloud environment like the one I showed you. How can you do that if you're going to forward? Forward really enables our users to really have a full visibility of the network infrastructure. Once you have full visibility, you can really do verification. And let me show you now how we can do verification within the platform, right, for cloud environments. Let's go to, again, to the AWS US West. So if you remember, a design pattern for this company was that in all the AWS cloud, all cross-VPC communication should pass through a central firewall VPC where the traffic is clean. So one possible way this policy can be violated is if there is a direct VPC peering between any VPC, any pair of VPC. As you can see here, if I visually take a look at this diagram, I can see an example of this violation. Now, the problem is that I may have many of these type of violation across the entire cloud estate. So how do I verify that across the entire platform? I can ensure compliance with this design by pretty much writing a query that ensures that there are no VPC peering directly connecting any two VPCs. Then I can turn this query into a verification check, which I will run whenever a new snapshot is collected and processed. And that's the power of the verification within Forward. So let me show you how we can do this, right? So I can go on the entry library. By the way, you should be familiar with the entry library. It really gives you a normalized structured data model of your network infrastructure, meaning we parse, we collect, we parse, and then we normalize this data. We put them in a data model, and you can write verification checks against this data model. You can see devices here. You can see cloud as well, right? You click on devices, you can explore pretty much the data model. We have HA, we have platform information like vendor OS. It looks like OpenConfig because it's based on that, interfaces and so forth, right? So at the same time, NQE gives you an SQL-like language, right, that you can see here. And using this language, which, by the way, you can master very quickly, you can write very powerful custom verification checks that are very specific to your environment. Here, what I did, I've written a small program pretty much to find all the occurrences of such VPC peering. So if I run this, I find 2 instances in which I'm actually having this peering. So as you can see, this becomes extremely powerful. As you can see, we run the check extremely quickly. So once this is defined, for example, I can go in the verification area where I have my AQ checks, I have dozens of AQ checks that we wrote, and I can enable, right? And you can see that this is failing. Then you can see the details, and you can really make sure that your cloud environment is always in compliance. The last thing I want to show you is in the security area, which by the way we introduced last year, is the security posture. So I can click here, and pretty much the security posture is a very common way for security teams to describe the expected connectivity between different areas of the network. In this matrix, you have rows and columns that correspond to different resource pools, like subnets in the cloud, on-prem subnets, hosts deployed in a VRF, and so forth. It's extremely flexible. And the value in each cell is either full connection, like the green, or it's partial connectivity, the orange, or there is no connectivity at all because something is blocked by an arrow. And for example, if I click the sales and ProdDB, I can see the details about the specific flow between these 2 areas. This is the traffic that could flow. And I can see a sample packet, which you can see very well going through again what we saw through the transit gateway, through the firewall, back to the transit gateway, and then reaching prod. And you can see again a very simple description, a visualization of the packet flow, which is going to be extremely hard to debug and to visualize, to understand if you don't have forward. I hope I was able to show you how comprehensive data collected or imported into forward is, plus deep analysis on top of this data. And all this help gives actionable insights across different teams under CIOs, specifically as we saw in the demo, NetOps, SecOps, cloud, and compliance, together with the application teams. All these teams are increasingly, as I was saying, all participating in our customer engagement and contribute from their budget towards purchase of forward platform for their organization. So thank you for your attention and have a great ONUG